Okay, so today's lesson is graphing quadratics from standard form, and the goal for today is to be able to analyze the characteristics of a graph of quadratic function in standard form. So the quadratic function, again, the parent function is x squared. That's the most basic function. The standard form is ax squared plus bx plus c. So you notice these a, b, and c, those are going to be numerical values. It's going to form a parabola. To find the axis of symmetry, this is the equation we're going to use. Okay, and the y-intercept is going to be the c value. So you notice there's a b value, which comes from here. There's an a value, which comes from there. And then the c is the value at the end. The c is the constant term. Okay, and that becomes your y-intercept. So let's look at the first examples. So find the vertex. So let's go, the vertex again is that turning point, the lowest or highest point. In this case, it's a minimum. So that's the vertex, the coordinate of the vertex. So we're just going to write vertex here. And the coordinate of that point, again, we always go x then y. So over 2, so positive 2, and then down to negative 2. Okay, and the equation of the axis of symmetry, I'm just going to shorten this to axis of sim. The equation of the axis of symmetry, so let's draw our axis of symmetry in. And remember, the axis of symmetry is always x equals, and whatever the x value is of that vertical line, the x value is at 2. And remember that the vertex, the x value, the vertex always matches the axis of symmetry. And then it says the y-intercept. So to find the y-intercept on the graph, we go to the graph, we look at where it crosses the y-axis, which is right here. And at coordinate of that point, x is 0, y is 2. All right, so from a graph, that's how we're going to do that. So let's look at the second graph. Again, we're going to find the vertex. So the coordinate of that point is 2, 4. All right, and then we're going to do the axis of symmetry. So we'll draw that dashed line in. And we look at the x value there, which is at 2. So x equals 2. Always write it as x equals. It is a line. It's not just a single point. So the line x equals 2 is that whole vertical line. And then y-intercept is where it crosses the y-axis, which in this case is right here. And the coordinate is 0, negative 4. For the y-intercept, the x-coordinate will always be 0 because we're on the y-axis. So now you're going to do exercise 1 and 2 following that same steps. And then we're going to look at example 2. So example 2 is now, instead of giving you the graph, we're going to find the same information, but we're going to use the equation. So the first thing we need is the axis of symmetry. And on the previous page, we had an equation. It said x equals negative b over 2a is how we find the axis of symmetry. So let's label our equation a, b, and c. And so we want to find the axis of symmetry. X equals negative, and then we need to put in the b, which is 4, over 2 times the a value, which is 2. So we have negative 4 over 2 times 2 is 4. Which equals negative 1. So x equals negative 1 is our axis of symmetry. Then it wants us to find the vertex. So to find the vertex, we know the x value is going to be negative 1. Because remember, the vertex is always on the axis of symmetry. So the x value is negative 1. To find the y value, we're going to use our equation. So y equals 2 times x, which is negative 1 squared, plus 4 times x, which is negative 1, minus 3. And then we're going to simplify this using order of operations. So we do exponents first. So negative 1 squared is 1. And then we're going to do our multiplication. So 2 times 1 is 2. 4 times negative 1 is negative 4. And then we're going to do our addition and subtraction from left to right. So 2 plus negative 4 is negative 3. 2 plus negative 4 is negative 2, minus 3 is negative 5. So the vertex, the x value is negative 1, the y value is negative 5. And then the last thing it asked us to find is the y-intercept. And if we look on the first page, it tells us that the y-intercept is always the c value. So we go back over to our equation, and the y-intercept is going to be 0, -3. Again, the x value is 0. If we plugged in 0 for the x, these terms would disappear, and -3 is our answer. So 0, -3 is a y-intercept. So let's look at B, doing the same thing. So the axis of symmetry. Right, x equals -b, so negative, let's label our a, b, c. -6 over 2 times a is -1. There's always an invisible 1, so -1. So we get -6 over -2, which is +3. So the axis of symmetry is x equals 3. Okay, then we do the vertex. To find the vertex, again, we plug into our equation. Y equals -3 squared plus 6 times 3 plus 4. And so -3 squared, we got to do order of operations, so we're going to do the 3 squared first. So -3 squared is 9 plus 6 times 3 plus 4. Keep order of operations, so we have -9 plus 18 plus 4. And if we add that together, -9 plus 18 is +9 plus 4 is 13. So our vertex is at 3, 13. And then finally our y-intercept, remember this is a c value, so it's always 0, and then whatever the c value is, which in this case is 4. So from standard form, these are how we're going to find the information. And then C, we got to label A, B, and C. Now you might say, oh no, there is no B term, or there's a missing term. So let's write this out. There's an invisible 1 here, so we have 1x squared. The term that's missing is the B term because there's no x. So we have plus 0x and then -9. So put in a 0x if there's a missing term, or a 0 wherever the missing term is. So that's our equation now. So to find the axis of symmetry, it's -b over 2a. So we have x equals -0 over 2 times 1. Anything with a 0 in the numerator is 0. So x equals 0 is our axis of symmetry. So to find the vertex, we're going to take our equation, and we can go back to the original one, and we're going to put 0 where x is. Remember, when you're plugging in or substituting, put parentheses around your number. So y equals 0 squared is 0 minus 9. So we get -9. So our vertex is at 0, -9. And then the y-intercept is 0, and then the c value. So again, I forgot to put the a, b, and c, but the c value is -9. So there's your y-intercept. Now, if you notice in this case, the y-intercept and the vertex are the same. That will happen if the vertex is on the y-axis. So now you're going to do 1, 2, 3 at the bottom, following these as your model, and then submit your paper when you're done.